Hi everybody, I'm Taisha, an application engineer at Keysight Technologies. In this video, we will discuss and explore the basics of using Keysight's device modeling extraction software Model Builder program, with the aim to provide new users a jumpstart in the world of device modeling. The basic topics we will investigate are the following: 1 through 8, frequently used tasks for crafting a device model, such as load data and custom model, tune model parameters, and run optimization. Let's get started. MBP runs on both Windows and Linux. Once the software is installed and the license is properly configured, MBP can start from either the desktop icon or from a command terminal window by simply typing MBP at the prompt. MBP's main GUI window opens with a default diode model project. This can easily be verified by inspecting the Windows title bar on the top. To select a MOSFET device, from the Model menu, pick the Select Model. The Model Type dialog will display. In the top panel, the project type, choose the DC radio button. Next, on the Model Selection panel, locate and select the device MOSFET, followed by selecting the BSIM4 version 4.8. At the bottom, there are options for using an HSPICE formatted model or SPECTRE formatted model. Choose HSPICE and click OK. A warning message will appear prompting that the current model will be cleared and the new project will be started. Select the Yes button. Notice that in the model parameter table down below, the level has changed to 54, which is the level number assigned for the BSIM4 model in HSPICE. It is the default model file that comes with the software. To load the example measurement data, go to the File menu, select Data, choose Load. A dialog will display. Browse to the example data folder, highlight one file, and Ctrl-A to select all the files at once. As soon as the data files are loaded, graphs appear immediately. The measurement data is plotted with broken lined curves represented by symbols, and model simulation curves are represented by solid lines. The simulation occurs instantly because MBP by default uses its built-in simulator. If you prefer to use a custom model, select the File menu, choose Model, and pick Load, and navigate to the example model in this demo. Now go to the Device Navigator panel. Notice that there are various devices with different channel width W, different channel length L, and temperatures listed in the device table. Below the device table is the Page panel. The Page panel captures setup information passed from the measurement data automatically, like IDVD and IDVG sweeps. We could click on a different entry in the device table to view the graphs for that particular device. Let's go back to the 10x10 device and try tuning a model parameter, such as VTH0. To tune a model parameter, simply search it in the search field by typing the parameter name, and when the drop-down narrows down to that parameter, hit the Enter key. Notice that a parameter tuner bar appears to the right. Observe as the slider bar on the tuner is moved to the left or right. The simulation curves change on the fly. At the same time, at the lower left corner of each graph, there is an RMS number calculated simultaneously that represents the error between the measurement and the simulation. Our goal is to tune or optimize the model parameters and lower the RMS value as much as possible. There are undo-redo icons, and we can always go back to a previous value if a tuning doesn't look right. To run optimization, we need to, number 1, select one or several model parameters, and number 2, we also need to select the regions on a graph or graphs. Those will be our target regions that MBP's optimizer runs for using the selected parameters. And to select a region on a graph, it requires holding down the Control key and dragging the mouse across the desired region. This will draw a rectangle. Let's select another model parameter, U0, to go with weightage 0. Here's another tip for selecting just one curve. To just select the VBS equals to 0 curve, double-click on the 0 legend label, then double-click the VBS label itself. This will only select the VBS 0 curve, and all other remaining curves will be disabled, and they will not contribute to the optimization. Now, click the green play button to kick off the optimization. Observe the curve fitting improves, and the RMS value gets smaller once the optimization is finished. To clear region selection, please go to the toolbar and click the Clear All Pages icon. During the model extraction process, it's possible to save the tuned model parameters back to the hard drive. Go to File menu, select Model, Save. The Save dialog will display. Browse to the specific location and give your file a name to save the file. Lastly, to save this project, that includes all the MBP environment settings. From the File menu, choose Project, Save, and the Project Save dialog will display. The next time the project is opened, the entire project will quickly restore. This concludes the video. To download the demo files, please click on the link in the description area below. Subscribe to our channel for more videos and to get the latest updates. And thanks for watching.